Fundamentals of organic reaction mechanism. The sequence of steps by which a reaction is supposed to take place is called reaction mechanism. Organic reactions usually involve changes in covalent bond present in molecules, and these changes may involve the breaking of bonds in reactants, electron displacement in bonds, and the energy changes accompanying the formation and cleavage of covalent bonds. Notations used to show electron migration. 1. Curved arrow notation. Curved arrow notation indicates movement or shift of a pair of electrons. And curved arrow notation is usually used to represent breaking of a covalent bond by heterolytic cleavage, addition reaction to multiple bonds, delocalization of bonds in conjugated systems. Cleavage of covalent bond, for example, in nucleophilic substitution reactions. An alkyl halide in presence of nucleophile, a pair of electron is shifted to the more electronegative halogen atom. So the movement of the pair of electron, that is represented by the curved arrow notation. Then another example is in addition reactions, electrophilic addition reactions. For example, when H plus, the electrophile, attacks propene, the pair of electron, that is the pi electron, gets shifted to one of the carbon atoms, and this movement of pair of electron, that is represented by this curved arrow notation. Then nucleophilic addition reactions. For example, carbonyl compounds in presence of nucleophile, the shift of pair of electron to the more electronegative oxygen atom, leading to the formation of the intermediate. Then curved arrow notation is also used to represent the migration of electrons in conjugated systems. For example, if we consider (1,3-butadiene), and the electron migration, movement of a pair of electron, that is represented by this curved arrow notation. So from the carbon which is devoid of the electron pair becomes positively charged, and the head of the arrow points towards the atom which gains the electron pair. Then double-headed arrows. Double-headed arrow is used to separate the contributing structures or the resonating structures. For example, in the case of benzene, the two kekulé structures are written like this. And half-headed arrow or fishhook arrow, it is used to represent the movement of a single electron. For example, when chlorine is exposed to light, homolytic cleavage takes place and we get free radical. And half-headed arrow is used to represent homolytic cleavage of a covalent bond, and the species which result as a result of this homolytic fission are known as free radicals. And the types of fission of covalent bond, there are two types of bond fission. One is homolytic fission and the other one is heterolytic fission. Homolytic fission usually leads to the formation of free radicals, and heterolytic fission leads to the formation of charged intermediates. And if the shared pair of electrons is equally distributed among the bonded atoms, that is known as homolytic fission. And in heterolytic fission, the shared pair of electrons is unequally distributed between the two bonded atoms. The intermediates having positive charge on carbon are known as carbocations, and the intermediates which arise due to heterolytic fission which carry negative charge on carbon are known as carbanions. So here you can see when the CY bond breaks in such a way that both carbon and Y gets the shared pair of electron, that leads to the formation of free radicals. And in heterolytic fission, if Y is more electronegative compared to carbon, the shared pair of electron will be shifted to Y. So the species carrying positive charge on carbon is obtained, and that is known as carbocation. And if Y is less electronegative compared to carbon, then during heterolytic fission, the shared pair of electron goes to carbon. As a result, we get a reactive intermediate carrying negative charge on carbon, and that is known as a carbanion. So charged reactive intermediates are formed by heterolytic fission and free radicals are formed by homolytic fission. And in organic reaction, a substance attacks the substrate or reactant to form an intermediate which then gets converted into product. The species which attacks the substrate is known as the attacking reagent, and that can be an electrophile, electron deficient, nucleophiles, nucleus loving or electron rich species, and free radicals. Electrophiles are usually deficient in electrons. They try to seek electron-rich centers. And electrophiles are of two types, positive electrophile and neutral electrophile. Positive electrophiles carry positive charge. Commonest example, carbocation, halonium ions X+, then H+, hydronium ion, then diazonium ion C6H5N2+, then nitronium ion NO2+, and nitrosonium ion NO+. And neutral electrophiles, they do not carry charge, but they are electron deficient. Usually Lewis acids are examples for neutral electrophiles. Example, AlCl3, BF3, FeCl3 and SO3. All these are examples for neutral electrophiles. Then nucleophiles, they are nucleus loving. That means usually they are negatively charged and they attack electron deficient centers. Nucleophiles are of two types, negative nucleophiles and neutral nucleophiles. Negative nucleophiles carry negative charge. Example, reactive intermediates carrying negative charge on carbon, that is carbanions, then halide ion, OH minus, OR minus, CN minus, RCOO minus, NH2 minus, etc. are examples for negative nucleophiles. And neutral nucleophiles, usually they carry unshared pair of electrons. And Lewis bases like ammonia, water, alcohols, ethers, amines, etc. are examples for neutral nucleophiles.